Welcome back to my channel. Please do so well to subscribe. Hit the subscribe button right now before I proceed. So hit it right now and hit the notification button too, so you get subscribed anytime I upload a new, so you get notified time I upload a new video. Thank you guys so much. So today we are going to be looking at a question on differential equation. Given a non-homogeneous differential equation of t squared second derivative of y with respect to x minus 2 first derivative of y with respect to x equals 3t squared minus 1. Now, given t which is greater than 0 and given y1 which is a function of t to be equal to t squared and y2 which is also a function of t to be t raised to power minus 1, obtain the particular solution of the equation using variation of parameters. Now, we all know that when solving the solution of a differential, especially a non-homogeneous differential equation, we're going to be having two sets of solutions. We are going to be having the particular solution and the complementary function. So basically, when solving the solution of a differential equation, especially a non-homogeneous differential equation, the solution of that non-homogeneous differential equation will be involving two sets of functions or two sets of solutions. The solution of that homogeneous differential equation, which is y, will be involving yp and yf. You can call this the complementary function. You can call this the particular solution. So now, but the question says obtain the particular solution. So basically, we are going to be obtaining the particular solution using variation of parameters. So now, basically, what we can actually calculate using variation of parameters is only particular solution. So now let's get down to it. So solution now, before we proceed, we need to know the formula of variation of parameters. Now, if you check my previous video on variation of parameters, there are actually two formulas for using variation of parameters. I treated the first one in the first video. Now, we're going to be looking at the wronskian method for solving or using my method of variation of parameters. So you can use variation of parameters using wronskian method. So now, the formula for calculating the formula for variation of parameters, or the second formula for variation of parameters, is given as a square dy d square plus b dy dx plus c to be equal to a function of x. Now, this is a non-homogeneous differential equation because of this function of x. So now, given this particular differential equation, second order differential equation, the solution to this using variation of parameters will be yp, which is the particular solution. Like I said, calculate variation of parameters. You calculate the solution of a differential equation using variation of parameters. You only calculate for particular solution, which is yp. So yp is equal to u1 y1 plus u2 y2. So this is the solution we are going to be working with, or we are going to be looking for. Now, we're given the equation. This is the solution. So now, basically, the formula for calculating u1, where u1 is equal to minus integral function of x times y2 divided by the wronskian of y1 and y2 dx, and u2 is equal to the integral of my function of x times y1 divided by wronskian of y1 y2 dx. So this is the formula for calculating variation of parameters using wronskian method. So now, but our question, we were given the independent variable is t, is represented by letter t. So we're going to be changing our formula. It's not with respect to x, it is y with respect to t. So our formula says, given the equation t square y prime minus 2y prime equals 3t square. Now if you can compare it with this equation, you see that this will map out with this and the remaining will map out with this. So basically my independent variable is not x, it's a function of t with respect to t. So my formula changes with respect to t. So my fx becomes ft, which is 3t squared minus 1, right? Then my u1 now becomes minus integral ft times y2 divided by wronskian of y1 y2 times, now it's not with respect to x, remember it's with respect to t, dt, right? Then my u2 becomes integral of ft times y1 divided by wronskian of y1 y2 dt. So now let's solve. So basically we just need to obtain u1 and u2 and calculate my particular solution, which says u1 y1 plus u2 y2. So basically we just need to calculate u1 and u2 and substitute it in this equation to get my particular solution, since we already have my y1 and y2 from the question to be t square and t raised to power minus 1. So let's solve. Come on. So from the question, my y1, which is a function of t, was given to be t square, and my y2, which is also a function of t, was given to be t raised to power minus 1. Now my u1 was given to be negative integral of ft times y2 dt divided by wronskian of y1 y2, and my u2, which is given to be negative ft times y1 divided by wronskian of y1 y2 dt. So now let's calculate the wronskian of y1 and y2. Know that wronskian of y1 and y2 be given by formula of the matrix of y1 and the derivative of y1, y2 and the derivative of y2. So y1, which is what? T square, y2, which is what? T raised to power minus 1. The derivative of y1, which is what? Now differentiating t square, we have what? 2t, right? And differentiating t raised to power minus 1, we have minus t raised to power minus 2. So the wronskian of two solutions says that wronskian of y1 y2 is equal to y1 y2 prime minus y2 y1 prime. So we're going to be applying this to this also, that is finding the determinant of this 2 by 2 matrix. We have this times this gives me t squared times minus t raised to power minus 2 minus y2, that is t raised to power minus 1 times this, t raised to power minus 1 times 2t. We'll be having now t squared times minus, now t raised to power minus 2 can also be written as 1 divided by 2 t raised to power 2 minus t raised to power minus 1 times 2t. So this will cancel this. We are left with what? Minus 1 minus, now this t raised to power minus 1 can also be written as 1 over t times 2t. This also cancels this. So we are left with minus 1 minus 2, which gives me minus 3. So this is wronskian of y1 and y2. So we have calculated the wronskian of the two solutions, so we can easily get my u1. So my u1, negative integral, my ft, remember we said my ft my ft is equals to what? Comparing this with this, my ft is 3t squared minus 1. So my ft is 3t squared minus 1. So we're having my u1 is ft times y2. So that is 3t squared minus 1 times, what is my y2? My y2 is t raised to power minus 1. So we have t raised to power minus 1 divided by my wronskian of y1 and y2 is what? Minus 3. So we have minus 3 dt. So taking the constant to the back of the integral sign, we have minus times 1 over minus 3, which will eventually cancel out, integral 3t squared minus 1 times 1 over t. That is changing this using law of indices. We have dt. So multiplying through by this, multiplying 1 over 3 all through, we have 1 over 3 the integral of 3t minus 1 over t dt. So integrating this, we have 1 over 3t 2 divided by 2, right, minus the ln of t. So multiplying through by 1 over 3, we have t raised to power 2 divided by 2 minus 1 over 3 ln t. So that is for u1. Now to calculate for u2, it says the integral of ft times y2 divided by wronskian of y1 y2 dt. So which is equal to my fc, which is what? 3t squared minus 1, right? So ft is 3t squared minus 1 times my y2, which is what? Sorry, for u2 is y1. So times my y1, which is what? T squared, right? So we have 3t squared times t squared divided by wronskian of y1 and y2, which we got as minus 3 dt, right? So which is equal to, taking the constant at the back of the integral sign, is minus 1 over 3 integral of, multiplying through by t squared, we have 3t raised to power 4 minus t squared dt. So now integrating my u2, which is equals to minus 1 over 3 integral 3t raised to power 4 minus t squared dt. So integrating this, we have minus 1 over 3 integral of 3t open bracket 3t raised to power 5 divided by 5 minus t raised to power 3 divided by 3. So multiplying through by minus 1 over 3, we have minus t raised to power 5 divided by 5, right? Minus, that is plus, minus times minus is plus, so minus 1 over, that's plus 1 over 3 times t raised to power 3 divided by 3. So we have in minus t raised to power 5 divided by 5 plus t raised to power 3 divided by 9. So I've got my u1 and u2, then I can say my particular solution, which is yp is equal to u1 y1 plus u2 y2. My u1, we got it as t squared divided by 2 minus 1 over 3 in t. So my u1 is t squared divided by 2 minus 1 over 3 natural logarithm of t times my y1, which is t squared, plus my u2, which got it as t raised to power 3 divided by 9 minus t raised to power 5 divided by 5 times my y2, which is t raised to power minus 1. So this is my particular solution. So thank you guys for watching. Please and please subscribe.